All right, so let's take a look at the following sequence and see if you all recognize this sequence here. Anybody recognize this? What type of sequence is this? Huh? Can I scribe cross on there? No, that's conversion for sure. Conversion means this is still 10 to a value. This will 10 to infinity. What does it look like? We did it last week. AP, right? This looks like an arithmetic progression because they keep adding what? They keep adding 4, right? That's okay? We keep adding 4. So if I wanted to get a formula to represent this, what would it be? It will be 1 plus n minus 1 by 4, right? Because it's an arithmetic progression where A is 1 and D is equal to 4, right? Of course, the formula could be simplified to something like this, 4n minus 3. All right? So what we have here is a sequence. Anybody knows how to convert a sequence series? From 5 or 4 or 3 probably, somewhere around there. How you convert a sequence series? Just add it. As no fields, just add it. Just add here. Add the terms, right? So a sequence, right, is this collection of numbers here that follow a particular pattern or follow a particular formula. Okay? And a series is the summation of a sequence. That okay with that? Right? So take this down. I'm gonna give you a little small note. Take this example down. And remember, I told you last week that the reason I did APs and GPs was you're going to have to watch a sequence and figure out how to come up with this relationship here. Ready, write this here. All right, then so. right? A sequence is a set of numbers. In a particular order. A sequence is a set of numbers in a particular order. Which follow a pattern or rule. Which follow a pattern or rule. Right? Each number in a sequence is called a term. Each number in a sequence is called a term. Anybody have a link to what we are here? Full stop. A sequence can be finite or infinite. I give up. I give up. A sequence can be finite or infinite.
Eli score a little bit.
Huh?
Eli score. E2.
I know, come back. No, all Chinese up. Right, so a sequence can be finite or infinite, and there are three types of sequences. There are three types of sequences. Anybody remember them? By the way, don't forget I remember them, right? Sorry about that. I apologize.
Yeah.
Right, there are three types of sequences. Number one, divergent. Divergent, for example, the one word that's divergent. Divergent means it will tend to a particular value. It's not going to tend to a value, right? Number two, convergent. Number two, convergent. Anybody could give me an example of a convergent sequence? Talk about it last week. Yeah, it tends to have value, but give me an example now. A GP when R a GP when R is between -1 and 1. Right? Write that down. A GP. Yeah, that's what we did now. Right? A GP when some to infinity exists, which is between when R is -1 and 1. Just don't know what else to say. And last one is what? What's the last one? Divergent, convergent, and one more. Oscillating. A periodic, right? Last one, periodic. Periodic. Yeah, all the way, all the way, all the way. Right? I want you to know the money, right? Yeah, please. I can maybe last few, man.
Oh, silly, yeah.
Right. Yeah, so conversion, divergent, and period. Right. How do we show a sequence is convergent? Right, so a sequence a to the n, right, is said to be convergent if remember that limit, right? If the limit of a to the n as n approaches infinity is some value L. That's the only way convergent, right? This must happen. Do you remember the rules for limits? How do we simplify limits? We have two techniques. Factorize and divide by the highest power. All right? Copy it down. Let's try a small example now. Yash. Send it?
See you guys.
Yash is sticking by Yash. Yash ain't send nothing?
You guys. So,
I just same thing I was using school, those sport, I kind of wasn't working.
Yeah, my one.
The first one wasn't working. Oh, I can take it, just take your phone and do it. I fell up this thing on you. All right, so I want to try one here. Let's see if a to the n plus 1 all over 2n squared minus 3 converges. Right? Let's see if it converges or not. Once it goes to our value, it converges, right? If not, it doesn't. Write it down, we'll together the time number. Yeah. Ash, yeah, we'll keep it, yeah. Yeah. So let me stop now. Shock. That's my whole now.
Fine art.
Shock, but I know see shock. You have to apply the limits. So we had to plug in the limits, right? The limit as n approaches infinity of n plus 1 over. If I were to just plug in infinity there and I'll get undefined, infinity on infinity. So we had to simplify. Try and factorize. Could we factorize that? Could we factorize here? Nah. And if we factorize here, that won't be helpful. So you had to divide by the highest power. What's the highest power of n? N squared. So you're going to get the limit as n approaches infinity. So you're going to divide every single term by what? N squared. N over 1 over all over 2n squared over n squared minus 3 over n squared. Or those who are doing the SVA, you all see the unit development, right? We had to run it through an AI, right? Right? I was sending 4 free ones, so you'll probably get in school. We had to run it through that, 20% or more, we had to fix it. I'll show you how to fix it, right? What is more than 20%? Are you okay with this? Yeah? So what will happen here? We will end up with the limit as n approaches infinity of 1 on n plus 1 on n squared over 2 minus 3n squared. What you do after? Keshav, what you do after? N is infinity, right? Substitute n is infinity. Anything divided by infinity is what, Cristiano? Huh? 0. Very good. So we get in 1 on infinity is 0. 1 on infinity is 0 by 2 minus 0. So the answer is 0. Right, Shaq? What does that mean, Shaq? So that means that convergent or not? No. It is, Shaq. It tends to have value. So it's yeah. I'd never say that to be 1, I said it's going to be L. Right? But this is not 1, eh? It has to be some limit. Anything once it's not undefined. Once it's not undefined, right? Remember all the who because we by PMI, eh? Remember that? We're gonna get test on PMI. Try this next one here, no? I'll give you a medium color here. Take it and see. Right? It is not good, right? Right, look it out. Right? What again? Oh yeah, I call and look it out quick.
So what I got? Yes.
How much longer can you limit? One, so that means it is conclusion, correct? Let's try one more. Right, so we have sequences to do, series to do, and then root side equation, and that's it. Right, so maybe like a two blockers. Right, so the limit as n approaches infinity of n plus 1 on n. I can't factorize, so I'm going to divide by the high power. So that'll be n over n plus 1 over n is n over n. Right? That will simplify to 1 plus 1 on n all over 1. Right? And when I substitute n is infinity, I'll get 1 plus 1 over infinity on 1. That'll give me 1. So therefore, conversion. Therefore, conversion. Let's do one more just square root now. Right? One like this came before. Hold on, that that's fine. I given you one with the square. That's one of the harder ones, right? Try this one now. Give that a square. Let's just see how you handle it.
You can look at all these ones. Yeah, so-
Try that here. And see what you come up with. Biggest problem there is the what? Square root, right? See if we can find a way to move it on. I just do this last one and then let's take a look at current prediction. So your screen is already, right? That's 20, 15, 20. The trick is what you're gonna do with that square root. What are the options on it? What are the options? Anybody? What would you do if you have something like this? What you can do? You can find a limit at the bottom. Okay, but then how you gonna deal with the limit at the bottom? That can work too, but it's the same thing if you keep it together. What would you do with that root? What? Right. You get in there. So can we do something like this? Is it possible to put the square root on the outside? Is it possible to put the square root on the whole thing? Yeah. So if I put the square root on the whole thing, what happens to the tops? You have to square it, right? And then if you remember your limit rules, if you remember your limit rules, you can work out the limit inside and pull out the half. So for example, this. I don't want to give you the answer, right? But if you have something like this, square root of x, sorry, square root of n, you could pull the square root outside and work out the limit. Right? If you remember your limit rules. All right, Adelia, so try that. Pull the square root out here and then pull the square root out of the whole limit after. Okay? Try that, let me see. And then work with the inside. Should be easier. But don't forget the square root on the outside, right? Dash that this up. Take your time, pull the square root out, and then simplify the inside. Then let's take a look at something called pure relation. And we have 2 minutes again. You didn't square up properly. Right, so your first step is to pull the root outside. So that'll be 2n plus 1 squared over n squared plus 1. Right? That's the first step. Next, you pull the square root outside the limits. And then you simplify in here. 2n plus 1 squared is 4n squared plus 4n plus 1 sharp. All over n squared plus 1. Then what do we do inside here? Focus inside here. What do you do inside here? No, you can't factorize. Right? You divide by the highest power. And finish. So you divide by the highest power, so you'll get 4 plus 4 on n plus 1 on n squared divided by 1 plus 1 on n squared. Right? As n approaches infinity, you just plug in your infinity and you'll get the square root of 4 plus 0 all over 1 plus 0, root 4, which is 2. Anybody get that one line? Anybody get that one line? 2. Okay, good job, Phil. Nobody is on that guy. Right? Next step. You okay with us? So again, you have to remember your rules for limits, right? So you can just look back over unit 1 and unit 1. Huh? It's not equal to anything. So how you get rid of this square root sign? Normally to get rid, you can square to both sides, but there's no both sides. It's an expression. Yeah, but it will still be the square root, will still be there. So if you want, instead of writing square root, you put it to the power of a half, yeah, that could work. But it's, at the end of the day, the square root signs to the power of a half still there.
Yeah, but
So you will get this to the power of a half, you'll get this to the power of a half.
yeah, not bad. I saw.
All right, so let's take a look at recurrent relation. Right, next, and a recurrent relation. Take a 1 minute break.
You know, sound like.
Right, hang on. So let's take a look at the recurrence relation. Right? Anybody know what a recurrence relation? You would have seen it in I can't know. Watch here. So this is technically like the formula for AP kind of thing, right? Recurrence relation where the one of the values helps you find the other value, basically. So for example, if I said U1 is 4 and I said to find U2, right? To find U2, U2 will be U1 plus 2. That's okay? U1 is 4, 4 plus 2 is 6. If I said find U3, it will be U2 plus 2, using this formula here. R is 2, 2 plus 1 is 3, 2, right? And I said that U2 was 6, 6 plus 2, and so on and so on. That's called a recurrence relation. You okay with that? This is unit 2. Right? Right? Recurrence relation, right? Similar to like a formula from AP or GP. All right, so head of recurrence relation, let's try a few. Relations. Recurrence relations, right? Right? A recurrence relation is one in which a recurrence relation is one in which a preceding term is dependent on, A recurrence relation is one in which a preceding term is dependent on what's preceding again, but I do want to come. Preceding one before. I feel I mix up the words. Preceding one before push-ups. I mix up the words. Infinite of preceding term. Sorry, I mixed it up. What did I say again? Sorry. A recurrence relation is one in which a term is dependent on a preceding term. Preceding before, right? Yeah, I'm mixing up the words. Preceding. All right, so let's try one, right? Oh, you're writing this. Anyway, you don't need to write it. I'll give you an next one, right? So I'll give you a new one here. Right, so let's take a look at this first one here. Let's take a look at this recurrence relation. So a term is dependent on the preceding term. All right, let's say I give you something like that. And I said that if U2 equal to U1, find possible values of U1. Right? This is the recurrence relation they give us. How we starting this? This is the most important, this is one of the important things here. They told us that U2 is equal to U1. How do I start working out something like this? You have to figure out what value you're going to put for R. What you'll do? So try to find U2. So U2 is equal to what? 5 over R is 1, right? 5 over U1 minus 4. You okay with that? The objective of this exercise is to find values of U1. So do I need U2 here? I have to get rid of this, right? So I know that U2 is equal to U1. So I can put, since U2 is equal to U1, I'll get U1 is equal to 5 over U1 minus 4. What you'll get now, Pete? Cross multiply and you'll get quadratic, right? So you'll get U1 squared minus 4U1 minus 5 is 0. And then you solve for U1. That's okay? Yeah. Copy it down. Let's try one now. The problem with this recurrence relation thing is that you're going to see it in PMI. Right? You're going to have to prove using PMIs that the relation is true. PMI is in it one, yeah, but not what we're going to do. Right? Kind of similar, yes. Kind of similar. Copy down. And then solve the quadratic, please. That's the one I'm going to. Just the one good bus, it's a okay now, and right, only possible values, right? Oh, yeah. If you only cut, that's available now. Somebody was saying. Uh, somebody was saying that the other pass you are available on see, I'm gonna down this place out. I don't like that at all. But once I get to you, once I get used to it. Oh, good. Pass you over the car 151. Class 991. For this one. Not that one, sorry. No, not that one. I mean, like 1 feet and then one. Once you can do everything there, I don't mind. What you all got for you one? 5-1. 5-1 minus 1. That's not my Wi-Fi given. No, 5 and minus. Right, try the one up on the screen then, huh? Huh? Yeah, I give it one. Okay. Like I'm gonna get you one. Some people complain. Try to see the one here. Try the one on top. I don't know what year it is, so just write any year one. Try this one here. That's fine. What? You want to look at my application. That is 11. 11. Actually. And this one easy, there's a plug-in values. But I guess the first two parts, I'll give you a hint with part two, right? Look at the first four terms and see if it follows any progression, you know. Yeah. So it follows a little formula. Alright, time up, let's what you come up with. Right, so we can easily see that T1 is equal to 11. T2, T1 plus 5, so I got 16. T3 is what? 21, and T4 is 26. So if you look closely, that's a what? AP. That's an AP with the first term what? With the first term is A, 11, and the common difference is 5. So they want a formula for t to the n. So t to the n is a plus n minus 1 by d. Right? You can make it look a little bit nicer. 5n plus. That's okay? That's all they want. So you have to identify what's an AP, right? That's the reason why I show you about AP and GP, because you have to remember how to create these little relationships. Copy down, let's do our next one. 2016 now. Number 3. Try this next one here. Part E only, right? Part E. Part B is sequences. Series, I mean. 2016. That is not our number. That's a line. That's like what? That's differential. I can't really zoom in more than that. But that's differential. Yeah, I can't zoom in more than that. Oh wait. Right, that's prime. Right up. Then we go into PMR. Okay, when U8 is that and U10 is that, find U9. Right, so the way you find U9, so you have to create an equation with U9 in it. Right, they show you how to find U3. U3 is U1 plus X by U2. Right, create an equation with U9 and it might help you.
So that's the US.
Sorry,
That's U.
U8 is 13x plus 1. U8 is 13x plus 1.
Boleh tak, Bu?
You know what they give you, right? They give you 8 and 10 and the 1 and 9. Ada? Harga value. Okay, let me see. I give you all this time and it's still one more time.
Yeah.
So U10, so I'm using N is 9, right? So that means U10. Wait, no, sorry, I used the wrong thing. U10, I'll go back and find U8 then. U9. Right. So U10 is equal to, remember, let it N equal to 9, right? 9 plus 1 is 10, 9 minus 1 is 8. That's an 8, yeah? Plus X by U9 to the pi, to the, well, right? U10 is what? U10 is 34X plus 1. U8 is 13X plus 1 plus X U9. You all recognize that you move everything on the left hand side, the 1 will cancel. You'll get 34X minus 13X is X U9. 34 minus 13 is what? 21. 21X is equal to X U9. And then if X will cancel, so U9 prime is 21. Got it up? Yeah. Right, bad news. Time for PMIs now. Last thing, take a minute break. And let's switch to PMIs. 34X minus 13X. I just substitute U10 and U8. They gave us U10 and they gave us U. And then I solve for U9. Right. Part B is C, I show you that. Already you can do that from point 5. I'll just do one.
So I'm going to put it on L.
Nice one. Maybe I'm up there because we are going on it.
Yeah.
Right next week, I'll just might do a little favor next, might put a little favor next week, right? I want to start a little bit later, like half an hour later.
So
Or we can go in our room and then when I finish with the phone files or anything other one.
so you last up that yes, on the floor.
Alright, so yeah, so you want to do that, right? So we start about half 5. Just half 7, yeah. We finish a little bit later. Yeah.
So
Half 7 to what time from the finish? Half 7. Oh, so it's 7. Or half 7. Our method is going to be mine. Right? I will do a paper with the form 5 lunch. They need 2 hours and 40 minutes. Maps. Maps. Listener. All right, Tolia. Here's what we need now. Here they gave us a PMI. Right? You remember the steps of PMI? Show it holds for N equals to 1. Assume it holds for N equals to K. And then prove it holds for N equals to K plus 2. But we have a big problem here. Right? The problem with sequences is that what they ask you to prove. They ask you to prove U to the N is equal to N squared minus N plus 6 over 2. You okay with that? They ask us to prove that. But in order to prove it, we need the part on top. We need the part on top. U to the N plus 1 is U to the N plus N. And I'm going to show you how to bring it in. That's okay? Right? So head up PMIs, start this one, and I will do the part 2 with you. Head up proof by mathematical induction and write down this number 3. It's very similar to what you did in unit 1. The difference is what you're trying to prove and what you're using, right? So we had a proof by mathematical induction. Natural number here. Number that for one, right? So there's no use to put it right.
Yeah, natural. But when you get that this number on there, right, go. Other choice.
Yeah, yeah.
Yeah.
Just decide converting. I appreciate it, right? You want to take on? Well, the baby can see anything. Start copy it down and then we're going to do the PMI together. Take this off, question off on the board. All right, that's cool, right? We're just doing one because of time, but I'll give you our next one to do, right? Right. So if you look here, these are the 5 steps in doing a PMI. What's important in these questions is you identify what is given and what you have to prove. Right? In this question, this is what you're proving. But this is what they give you to work with. That's okay? So you are using this in step 1 and 2. When you reach step 3, we use what is given. So in step 3, we're going to use this information here. That's okay? Step 1 and 2 is just like a normal PMI using this. But step 3, we start using this here. And you have to show that that is equal, step 3 equal, so you have to prove it, right? That's okay? So let's start. You all ready? Watch it here, the first few steps easy. So when n is equal to 1, u to the 1, remember we're using this. The only time we're using this is down in step 3. So ignore what is given until we're using this for step 1, right? But we're not using this until step 3. So U1 is equal to 1 squared minus 1 plus 6 over 2. This will give you 3. Therefore, it holds. You'll see that? U1 is 3. So it holds. Everybody okay with that? Now, we have to do step 2. We have to assume true for n equal to k. So I am using this and I'm going to replace n with k. So I'm going to get uk is equal to k squared minus k plus 6 all over 2. Right? And then we have to show now. Show it holds for n is equal to k plus 1. So all I'm going to do is I'm going to put k plus 1 where I have k. So u to the k plus 1, notice I'm still using this. It's k plus 1 squared minus k plus 1 plus 6 all over 2. Everybody okay with that? Let's simplify it and make it look a little bit nicer, right? Right? But I'm putting k plus 1 in here. So it gives us an idea of what we have to prove. This line here is what we're going to have to prove, right? K squared plus 2k plus 1. I expanded this. Now I expanded this plus 6 all over 2. So now I know that u to the k plus 1 is k squared plus k plus 1 plus 6 is 7 all over 2. Huh? Minus 1. K squared plus 2k plus 1 minus k minus 1 minus 1 plus 5 to be 6. Minus 1, right, yeah, must be 6. So we're trying to prove that. Right? Everybody watch here now. You're going to write it after. Here's the important step. This here is what we're trying to prove. So we are trying to prove. Trying to prove this. Everybody clear with that? How do we prove this? To prove this, you'll recognize, if you remember your unit 1, there's always something here. But we do have it, so you recognize that? So we need to get something to prove. So we know this. We know that u to the k plus 1 is equal to, we know that u to the k plus 1 is u to the k plus k. That's what we know. Because we were given this, so we know this is true. U to the k plus 1 is equal to u to the k plus k. Everybody okay with that? And then, where do I go from here? Do I know what is u to the k? U to the k is right here. Right? So u to the k is equal to k squared minus k plus 6 all over 2 plus k. Everybody okay with that? What do I do? Find the LCM. How to do that? Find the LCM. U to the k plus 1, everything over 2. Again, k squared minus k plus 6. 2 by k is 2k. 2k minus k is plus k. Is that the same thing? Yeah. Right? Therefore, by proof, by mathematical induction, it holds for all n is an element of n. Right? Don't forget this last statement here. If we can squeeze in one? Yeah?
So right now,
And then yes, then yes. What is yes? Say good. Huh? Part 1 is just putting values. Part 1 is U1 is 3. U2 is 4. Then keep putting in values there. U3 will be U2, which was 4, plus 2, which is 6, and so on. Right? That's plugging it, plugging of elements. Right, I know you mightn't do it, but after that faith, that's faith will lead to it. Send one page to do, right? But the PMI in series really, right? It's just type of you get one. Right? The only problem with these is that they'll give you inequalities in prove PMI by inequality. Actually, that's a good idea, Sapphire. I'm gonna give you one time for inequality. I like your idea. Do it. Wait to finish. Copy it down.
Yeah.
So you're ready for your next one. Huh? Yeah. After you. Send it. Right, that's a hard one, then I give you an easy one, right? Right, try that for homework, please. Right, copy it down. Next week we'll start a little bit later on method 2 to remind us.